Hello everyone. Now we are going to see about the history of development of periodic table. Yes, it is a history of periodic tables development, but it is not a boring history. History of periodic table is little bit of interesting. How comes? Let us see. As we already have discussed, the classifications need was there by means of the new discoveries of element. As new discoveries of elements are starting every year, so scientists were thinking to classify these elements in a unique way. So because of that, in 18th century there is a classification of elements started. So according to that, in the 1815 the first classification made. Who made this classification? The name of scientist was William Prout. This William Prout make a one theory called as unitary theory. Now what is this unitary theory stands for? As William Prout is the first person in this world who started a classification of an element, which was the major problem at that time. So he started by very fundamental part. As at that time we were only having information of atomic masses. So in case of atomic masses, what kind of element is suitable to remember those elements by using the atomic masses? This is the question in front of William Prout. So he started thinking and make one theory called as unitary theory. As we know, the unit stands for a very single small particle. So this single small part he consider as a hydrogen atom. Why only hydrogen? But because hydrogen has only one atomic mass, and this theory is totally depend upon atomic mass only. So hydrogen, as it has only one atomic mass, so he consider hydrogen as a unit and made this theory. How? Let us see. By using this, suppose if we know the magnesium, so the magnesium's atomic mass is 24. That means William Prout is supposed to say by using this theory that magnesium is made up of 24 units of hydrogen atom, like that. If we can take an example of sodium, which is having atomic number of 23, so then how can we pronounce by using unitary theory? Definitely by we can pronounce by using unitary theory like that. The sodium is made up of 23 units of hydrogen. That means every time whenever we need to remember that element, according to this theory, we're supposed to compare the atomic mass of that particular element with the atomic mass of hydrogen. Why? Because hydrogen is considered as a unit by William Prout. So this was the question, because every time we supposed to compare that part with the hydrogen, so again there is a lengthy process. So that is why it is not applicable to each and every element. So this theory fails at that moment. But can this classification ends over here? No. Just beyond this discovery of the unitary theory, after also there is a classification continues. As the unitary theory of William Prout has some kind of drawback, so it get ruled out from the concept. But in the year 1817, that means only after a 2-year sleep of the unitary theory's existence, there is another concept who comes into existence. Who made this concept? The name was Dove-Reiner. Dove-Reiner was the scientist who made another attempt after the drawback of unitary theory only within 2 years. And Dove-Reiner again made some kind of assumptions by his work and called as Dove-Reiner's triads. That means Dobereiner make an arrangement of three elements in a particular group, in which he arranged those elements in such a fashion that whenever we can take an average of atomic mass of first element and the last element, so we can get a round of the atomic mass of the middle one. So this is the theory of Dobereiner triad. How it is, we can explain it by taking an example. Suppose if we are having a three elements triad, that is lithium, sodium and potassium. So which is the first element in this triad? Lithium. So and what is the atomic mass of lithium? It is nothing but around 7 plus. What is atomic mass of potassium? It is around 39. And we have to take average, so divided by 2. What is the answer? Obviously it is around 23, and 23 is nothing but the atomic mass of the middle one, that is the sodium atom. This is how the effectiveness of Dobereiner triad have at that time. That means we just have to take an average of the first and last element's atomic mass to know the atomic mass of the middle one. But there was again a question in front of us because the discovery of an elements in a random manner. So he made only 3 triads at that times. That means he cannot make this theory applicable to each and every discovery of element at that moment. He only gets success to make only 3 triads, and remaining elements get unclassified. That means this theory again ruled out from the concept. So can here the stop of the classification? No. Another classification was again attempted in the year 1854. Now who is the scientist? The scientist's name is J.P. Cook. He made another development called as homologous theory. Now what is this homologous theory stands for? We know that the homo stands for same and logos stands for study. That means this J.P. Cook made the arrangement of element in such a manner that we have to study only a similar kind of study of an element at a time. So what kind of study we can make at a time by using a homo word? He consider as a properties of an element. But can you tell me, can properties of each an element who are discovering at a random manner are equal? Definitely not. So this is what the question again in front of us, in front of the homologous theory. Because this homologous theory is totally depending upon the similarity of the properties of every elements which have discovered at that time, and which is not possible because the discovery of element is at the random positions. So the elements which are discovering newer and newer, they are not supposed to have the similar kind of properties with the previous one. So there is again a question in front of us. So can this theory make a sense for the classification? Definitely not. So this theory again ruled out. But in the year 1865, there is another attempt by another scientist called as John Newland. Newland was another scientist who made another attempt of classification of an element. See, the classification of an element started at the year 1815. Now we have reached the year 1865. That means such a huge time we have spent, but still we are struggling to find the classification technique of an element. Many of the scientists attempted their work towards the classification, but they did not get success for the classification of the entire element. So Newlands was in the dilemma, what kind of things and what kind of factors to be added in my theory to do the classification of the entire element. So this is what the question in front of Newland. So he started arranging some of the elements in a one line according to their increasing of atomic mass. That means the first element having the lesser atomic mass, whereas the eighth element is having the more atomic mass. So because of that, the first element has a least atomic mass and the eighth element has a more atomic mass. But how it? He made the arrangement of elements like that. Suppose if we take an example, there is a series called as lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. How many elements are there? 1, 2, 3, 4, 5, 6, 7. That means all these 7 elements are with their increasing atomic mass. That means the atomic mass of lithium is only 7, beryllium atomic mass is 9, and it is 11, 12, 14, 16 and 19. That means the elements were arranging by Newland in an increasing order of their atomic masses. But there is another main factor there in the theory of Newland. What is it? He said that every first element shows the resemblance in kind of properties with the every eighth element. How many elements are there? 7. So where supposed to 8 element stands for? It's supposed to stands at this position. That means below the lithium, and lithium is again having atomic mass 23. That means obviously more than a fluorine. So all these elements are in the increasing order of the atomic mass, but the first element, that is lithium, showing some kind of similarity with the sodium in case of properties. That means first and eighth element has a resemblance in properties. So Newland made some kind of comparison of this experiment with the musical octaves. In case of musical octaves also, there is some sa, re, ra, ma, pa, dha, ni, and eighth one is again sa. That means the first element and the last element has some kind of the similar notes. The same thing was happening here. The first element, that is lithium, has the similar property with the sodium. Whenever it increases their atomic masses in a regular fashion. So as these are the 8 elements in a one line, so Newland made their name as a octaves, and they refer to as a Newland's octaves. So what is Newland octave? Newland make arrangement of 8 elements in such a manner they can arrange in an increasing order of atomic mass, but the first element and the 8th element is supposed to have a similar properties, just like a musical octaves. So Newland made a name for this theory as Newland's octaves. But this theory again ruled out. Do you know why? This is such a nice conceptual theory by Newland. But again, there is a question behind the not fulfilling needs of the classification by theory was that the new elements are discovering and they supposed to have a higher number of atomic mass. So can they fit into this theory? Definitely not. This theory is suitable only up to calcium, and calcium has atomic mass only is of 40. That means the elements which are having more than 40 atomic mass, they cannot be considered by a Newland's octaves. So this is what's the drawback. So this theory again ruled out even after doing a nice work in a classification of an element. So the next attempt in after only a 4 years, that is 1869, was done by a scientist called as Lothar Meyer. This Lothar Meyer again made the elements classification by using a properties. So he used a chemical properties at that time. Properties were also get used by this J.P. Crook by homologous theory. But homologous theory was depending upon physical as well as chemical properties. But the Lothar Meyer is using only chemical properties. That means he made a group which has properties which are similar. Which are they? chemical property. He made a group of properties, chemical properties in a group. They are similar to each other and they made a group for the same. But again, because of the some of the drawback, because of the newer entries, this theory fell down, because the kind of properties of noble gases are not suitable for this one, because the noble gases has the completely different property than the other one. So this was the drawback of Lothar Meyer. But at the same year, there is another scientist called as Mendeleev. This Mendeleev made a revolutionary effort in classification of an element. How does? Mendeleev made all the classification of an element by using increasing order of atomic masses. But for that sake, he made one table. He made one table called as periodic table, and make also a law called as Mendeleev's periodic law. What was that law? He said that the physical and chemical properties of any elements are the periodic functions of their atomic masses. That means, as we can make a table of increasing order of the atomic masses, so we can have a regular intervals repetition of a properties. So just consider, if we have a property A here, then B here, C here, D here and E here. So after certain time, the properties are again A, B, C, D, E. After again certain time, the properties are again A, B, C, D, E. That means after regular interval, the properties are repeating in a regular fashion. So this is nothing but a periodic part. So he given a name as a periodic law and make a name for this table as a periodic table. And do you know, the Mendeleev was the first person in this world at that moment who made the classification of entire element who were classified at that moment. He also made some empty spaces in his table and conclude that whenever the newer entries of elements will be there, they can be fitted here only. That means he is the only one person who classified elements as well as doing some kind of prediction for the newer entries also. So this is the revolutionary work made by a Mendeleev in terms of classification of an element, and here it is how the periodic table comes into existence. Thank you.